All right, so good afternoon. I wanted to get this done much earlier than now, but meeting after meeting, and well, here it is. It's 3 o'clock or 3:13. So anyway, so today here's what we're doing. We're doing parabolas. We're going to graph parabolas in standard form and find maximum values. So there's going to be some fun stuff later on with the word problems. Anyway, to find to graph parabolas, we need to know where the vertex is. And we've actually looked at this before. We have this little tiny formula, x equals negative b over 2a. And that's the formula we need in order to do everything we're doing today. So x equals negative b over 2a tells us the x coordinate of the vertex. And then we take that and we plug it in, and then we'll end up with the y coordinate of the vertex, and then we're almost done from there. Okay. And we remember that a is the number that's in front of x squared, b is the number that's in front of x, and c is the number out here all by itself, even though we don't need that for the formula. So we're going to find out what the x value is for this problem. And so it says negative b, and in this case b is already negative 2, so we're going to do a negative 2, which of course is positive 2, over 2 times a. Well, of course, a is just 1. There's nothing there, so we say it's a 1. So we got 2 times a. A is 1, so 2 times 1 is 2. So we see that x equals 1. And what we need to do now is find out what the y value is. So we just plug in 1 here, and we'll figure out the y value. So then we're going to get y equals 1, right? That's this guy right here, 1 right there, squared, because we're squaring it, minus 2 times 1, right? Just plug in the 1 right in where the x is, next to the 2, plus 3. So we got 1 squared is 1, negative or minus 2 times 1, which is minus 2, plus 3. 1 minus 2 is negative 1, plus 3 is positive 2. So y is 2. So that means our vertex is 1, 2. X value there, that's 1. Y value there, that's 2. So there's our vertex. So now we can start doing the graphing. And here we are at 1, 2. So 1, 2 right there, over 1 up 2. And then we remember that a is kind of like the slope, so that means we're going to go over 1, up 1. Right? We always do go over 1 and then that number there. So over 1, up 1. Over 1, up 1. And of course, if a was 3, we'd go over 1, up 3, and over 1 this way and up 3. And then we connect the dots in a curvy kind of way, not pointy. Making sure it's curvy, because if it was pointy, it'd be absolute value, but this is a parabola. So there it is. There's our first parabola, all done. All right, so the key formula is negative b over 2a. So we're going to do the same thing right down here. Same formula, same stuff. So we're going to have x equals negative b over 2a. So in this case, b is 6, so that's going to be negative 6 over 2 times a. A is 1, so 2 times 1 is 2. So x is negative 3. And then we're going to plug in the negative 3 there and figure out what the y is. Not feeling very happy about this. I'm going to actually change this to plus 8. There we go. It's going to make our lives definitely better. Plus 8. Okay, so we got y equals, and we're going to have negative 3 squared. So we got negative 3, put that in parentheses, square it, plus 6. Negative 3 goes right in there where the x is, times negative 3. And you can see in a moment why I changed this to 8. So negative 3 squared is positive 9. 6 times negative 3 is negative 18. So 9 minus 18 is negative 1. I'm sorry, negative 9 plus 8 is going to be negative 1. So before, when it was negative 2 or whatever it was, that was going to get us negative 11. That was going to be irritating and annoying to graph. Okay, so our vertex is negative 3, negative 1. So we set up our x, y coordinate plane here. and we do negative 3, negative 1. So negative 3, negative 1 is right there. And then, again, we do the slope situation. Guess I could have gone this way. So the slope is 1. Not really, it's not really slope, but we just treat it like it's slope. So we go over 1 and up or down that number right there. So in this case, it's positive 1, so we go up 1. So over 1, up 1. Over 1, up 1. And then again, we connect the dots in a curvy kind of way, or at least try to make it curvy. I'm clearly no Bob Ross. There it is. A nice little parabola. A happy parabola. Okay, so let's jump over here to the other side. And so here I changed A, so it's not 1 anymore, it's 2. So, we just have a little bit of variety here. So again, we're just using our little parabola situation here. So we got negative B. B is already negative 4, so we make it a positive 4. Over 2 times A. Well, A in this case is 2, so 2 times 2 is 4. So x equals 1. And again, we just take the 1 and we plug it in where the x's are so we can find y. So we got 2 times 1 squared minus 4 times 1 plus 1. So 1 squared, of course, is 1 times 2, she is 2. Negative 4 times 1 is 4, or negative 4 plus 1. 2 minus 4 is negative 2, plus 1 is negative 1. So we got 1, negative 1 is our vertex. So we got 1, negative 1 is our vertex right there. And then from there, we're going to do the whole slope situation. And that means we're going to go over 1 and up or down that many. And again, it's positive, so we go up. So it's over 1, up 2. Over 1, up 2. And again, we connect the dots in a curvy kind of way. That was a little bit better, not so much. Okay, there it is. There's your parabola. That's that parabola for that equation right there. Okay, and last one of these. So I'm going to give you a moment to try this one all by your lonesomes, and you should pause the video right now. You should try this right now. And I know I'm probably only talking to Bryn and Caitlin, but, try it on your own and pause the video and do it right now. So I know you had a great time pausing the video and actually doing this problem. So we're just going to whip right through it. So we got x equals negative 6 over negative 6, which again turns out to be 1. Tried to make these problems pretty easy for you. And the y is going to be negative 3 plus 6 is positive 3 plus 4 is 7. So y equals 7. So we got 1, 7 is our... Well then, we'll manage this. So we got 1, 7 is our vertex. 1, 2, 3, 4, 5, 6, 7. There it is. 1, 7 is our vertex. And our slope, in air quotes, right? It's not really slope, but we treat it like slope, negative 3. So we're going to go over 1, and this says negative 3, so we're going to go down 3 this time. So from here we're going to go over 1, down 3. 1, 2, 3. Do the same thing over here. Over 1, down 3. 1, 2, 3. And by the way, we can see that the y-intercept here is 1, 2, 3, 4. Hits the y-axis at 4. Y-intercept, 4, right over there. All right, so again, we connect the dots in a curvy kind of way. And there you have it. There's an upside down parabola for us, because that's a negative. Okay, so let's, I need a calculator. Okay, got my calculator right here, as you can see. All right, so as I said, the other thing we're going to do besides graphing is find maximum values. So I tried to find some fun, quote-unquote, fun problems for us to do in order to maximize. And you can see that the maximum actually occurs where the vertex is, right up here. This is our vertex, but it is also our maximum point. So in order to find the maximum value, you just have to find the vertex. And finding the vertex is really just a matter of finding negative b over 2a. So that's what we're going to do. So here it is. We have a woodland jumping mouse is given, the height of a woodland jumping mouse's jump, I guess, is given by h equals negative 0.2x squared plus 1.3x, where x is the horizontal distance that the mouse has jumped. What is the mouse's maximum height? Okay, so you can imagine what's going on here. We got a little graph situation right here, and here's the mouse starting right here, and it jumps and it lands down here. And so this is the x amount, this is the horizontal distance, and this is the h amount. How high has the mouse jumped? Okay, so we want to find out how high the mouse has jumped. So we are going to find the maximum, which is going to be where the vertex is. So again, it's x equals negative b over 2a. In this case, b is 1.3, so it's going to be negative 1.3 over 2 times a. Well, a is negative 0.2. Double that, that's negative 0.4. Negative 0.4. You know what I'm going to do? I'm going to make our lives a little bit easier here. I'm going to change this to 0.12. I'm going to change this to 0.12. This is a different breed of mouse, so different species of mouse, so it doesn't jump quite exactly the same. So we got negative 1.2 divided by 0.4 turns out to be, you guessed it, 3. So when this was 13 divided by 4, it didn't come out so nice, so this is going to be 3. So x equals 3. So 3 feet. So these little guys can jump really quite far. So we find out here that the maximum height that the little mouse jumps occurs 3 feet after it actually starts to jump. So that means that this mouse can jump 6 feet. It's quite a jumping mouse here. Okay, so we're going to plug the 3 right into here and here, because that's the way we're going to find the maximum height. So the height for our little guy here is x equals negative 0.2 times 3 squared plus 1.2 times 3. And 3 squared, of course, is 9. So we got negative 0.2 times 9. And 1.2 times 3 is 3.6. And this is negative 1.8. Negative 1.8 plus 3.6 equals positive 1.8. So our little guy here has a maximum jumping height of 1.8 feet right there. And that happens when he's jumped from here in this direction 3 feet. So after he's gotten to 3 feet, he's going to be 1.8 feet up in the air. So he's quite a little jumper. Okay, so here's our next little application problem. So this is all about Hansen right here. So Hansen used to throw the shot put way back in the day. So Hansen's shot put throw height is given by h equals blah, blah, blah. This formula, it's this equation right here. And you know what I'm going to do? I'm just noticing this, that I can make my life a little easier by calling this 0.8. Yeah, that's going to be better for us. H equals negative 0.01x squared plus 0.8x plus 6. And 6, of course, is, as you may have guessed, this is going to be the height at which he releases the shot put, 6 feet in the air, or above the ground when he releases it. So where x is the horizontal distance, just like the mouse jumping just a minute ago, in feet, what is the maximum height? All right, so we're going to do the same thing. So we got x equals negative b over 2a, because the maximum is going to happen where the vertex is, and this is the way we find vertexes. So this is going to be negative 0.8 over 2 times negative 0.01. So we have, oh my, he can really throw this thing, can't he? So we have negative 0.8 over negative 0.02, and holy God, that's 40 feet. That means that Jacob is going to have thrown the shot put in such a way that the maximum height occurs at 40 feet. So again, if we make our little graph here it is right here. So it reaches its maximum height at 40 feet. So he's actually going to be throwing it almost 80 feet over here. And so just to put it in perspective, the school record is 44 feet. So this was really quite a throw here by Hansen. Okay, so anyway, so 40 feet is the x value that we're going to put into here. And then we're going to find out the height after we put 40 feet into those places. So we got h equals negative 0.01 times 40 squared plus 0.8 times 40 plus 6. Good thing I got my calculator with me. So 40 squared is 1600 times 0.01 is 16, actually negative 16. Negative 16. And then 0.8 times 40 is 32. And plus 6. So negative 16 plus 32 is positive 16. Plus 6 is 22 feet. That's the maximum height right there. So maximum height 22 feet, and clearly he threw almost 80 feet. So, but all we wanted to know was what was the maximum height. So good job, Jacob. All right, so here we go. This is timely here. So, well, actually, no, the next question is timely, but I'm going to actually cut the video right after this problem right here. So after Belle finished a new training program, she was able to throw a ball 96 feet per second. I actually contacted her today, and she told me that she's able to pitch at 55 miles per hour, which is unbelievably fast. And when I turn that into feet per second, that's 80.67 feet per second. But again, as you saw, some numbers work better than others, as I had to change them in the lesson. So as it turns out, 96 actually works really well for us. So that's why I had her go through this nice little training program so she could throw the ball even faster. So she's throwing the ball 96 feet per second after her training program. Right now it's 80. So the height of the ball is given by this formula right here. H equals negative 16t squared plus 96t plus 5. What was the maximum height? So 96 is the speed here that she can throw it. 5 is the height at which she releases the ball straight up. And then negative 16t squared, this bit right here, this is the gravity pulling downward. And you can see it's downward because it's negative. So we're just going to do the exact same thing we just did. We want to find the maximum height. So in this case, t is what we're looking for, not x. And t is in seconds, and h is in feet. So we got t equals negative b over 2a. So there's our b right there. Negative 96 over 2 times a. Well, 2 times negative 16 is negative 32. And that, of course, makes 3, as in 3 seconds. So we want to know what's the height of the ball after 3 seconds. Well, we're going to plug this right in here. And I'm just going to speed right through this. So 3 squared is 9 times 16 is negative 144. Plus, we got 3 here. This is going to be 96 times 3 is 288. Plus 5. Negative 144 plus 288 is positive 144. Plus 5 is 149 feet. So there it is. There's the maximum height that Belle can throw the ball after her new training program. So there you go. There's your video on maximum values and graphing parabolas. Hope you had a good time. Bryn and Caitlin, and maybe Hansen watched because he would get a chance to see his record throw here for the shot put. Thanks. Be safe. I'll see you guys soon.